Alright, welcome back. So far our robot can move, but it cannot perceive its environment. In this module, we will add a camera sensor. This allows the robot to receive visual information. In ROS2, sensors are publishers. They send data to the system through topics. This data can then be processed by any node. This is how perception pipelines are built. A camera publishes two main topics. First, the image itself. This is raw pixel data. Second, camera informations. This includes calibration parameters. The important idea is any node can subscribe to these topics. You can replace the camera, the processing node, and the algorithm without changing the rest of the system. We start by defining the camera in the URDF file. We create a new Xacro file. This keeps the robot modular. The camera is just another link. It has visual, collision, and inertial properties. We also define an optical frame. This is critical. ROS2 uses a standard convention for cameras. This ensures compatibility with vision algorithms. Finally, we attach the camera to the end effector. This simulates a real robotic arm without mounted cameras. Now we add the simulation behavior. The sensor tag defines a camera sensor in gazebo. We configure resolution, field of view, and update rate. Then we add ROS2 plugin. This plugin converts gazebo data into ROS2 topics. We also define a namespace. This keeps topics organized. Now we include the sensor file in the main robot description. This integrates the camera into the robot model. This modular structure is important. It allows you to add or remove sensor easily. We rebuild the description package, then we launch the simulation. Watch gazebo. You should now see the camera attached to the robot. Now we verify the camera. We can list the topics. We should see image and camera info topics. Then we check the publish rate. This confirms the sensor is active. If topic exists and publish data, the pipeline works. Now we will visualize the camera. We use ROS2. We add an image display and select the camera topic. You should now see what the robot sees. This is the foundation of perception systems. Now we create a Python node. This node subscribes to the camera topic, and we use Cephei bridge to convert ROS2 image to OpenCV format. This is the standard bridge between ROS and computer vision. Now we run the subscriber node. It receives image in real time. You should see logs with image size, and optionally a display window. This is how perception nodes are built. They consume sensor data and process it. Sensors in ROS2 are fully modular. You can replace the camera, the algorithm, the hardware without changing the rest of the system. This is the key advantage of ROS2. In this module, you learn how to add a camera to a robot, how sensors publish data in ROS2, and how to visualize and process images. You now have a perception pipeline, from sensor through topics and processing nodes. This is the foundation of robotic intelligence. Next, we will master visualization tools with ROS2.